Our final panel before the youth panel comes in to tell us what they daydreamed and vote on our concepts from the weekend is about emerging interfaces, and that's extremely broad. So you're also going to hear from 3 guests who I think will take slightly different directions about what they think are some examples of emerging interfaces and some ways that we can think about taking advantage of that for learning. So first, we're going to have Jordi Borras, who is a designer who originally started in Barcelona, but came to the U.S. and working for a few consumer product firms, including Marco Perry, Smart Design, and has won numerous awards. Actually, all 3 of our speakers have won numerous awards, so I won't list all the awards. But right now, he's working at a company called littleBits, so he'll talk more about that. And then we have Zach Lieberman, who is an artist, a professor, just many, many things, who is also actually Adam. Are you Adam here too? Okay, no, not an Adam here. Okay, now he's a Professor Parsons. And then we have Kyle McDonald, who again has won numerous awards and both have worked in various festivals and museums and etc. But mostly are being very generous with their time to share some of their inspirations to help us with our brainstorming today. Okay, great.
Hello everybody. So when Cindy invited me to talk in the beginning, I got a little scared because I thought, what am I going to say to technologists and teachers? I'm not a technologist, and I've never been into digital interfaces. So at the beginning, I started thinking about inspirations, and I thought, there's no way I can make these guys discover something that they don't know already, because you probably know from the technical point of view, you guys know more than me. So I thought that actually what I might be lacking might be more valuable for you, because it's an internal point of view that you guys probably don't never consider. And so I started designing furniture, and 10 years ago I was doing research for Herman Miller and Human Scale and other companies, and basically they were asking us how are going to be the interfaces in 10 and 20 years at the office. And really, I mean, up to now the work habits have been changing, but we're still working tables and physically nothing changed. So all the efforts where we were trying to envision how the technology was going to be, how would we integrate the technology, and actually, what we were envisioning now is real, like like lean motion, for example, these systems that they recognize natural movement. They're able to recognize individual fingers, and with a really tight definition. But so we were trying to design and embedding all that we could do is embed this technology into furniture. But it's basically disclosed this like script, and there's nothing I can do as a designer more than place it in one place or another one. There's really nothing I can experiment or I can do myself to improve the experience of the actual interaction. And a few days ago I saw this, and I thought that was in line a little bit with what we were doing. It's a little more open because in this case what they're doing is with 3D printers. They're creating these light packs inside the objects. So in a way that only using the optical properties of the material, you can have tangible interactions. In this case, for example, what he's doing is transporting the display, which is under this chest piece, and it's bringing the light into the front panel only using the geometry of the piece. No? I thought that this was a little more accessible, and maybe it would allow designers to experiment a little bit more. For example, with an IR emitter and a receiver, with something very simple as the transparency of the plastic, you can interact by changing the reflection of the beam and changing the destination of the signal. it's very low-fi, but it's not low-fi because not everybody has access to 3D printers, and these are very specific 3D printing kind. It's a UV-sensitive material, so it's still very close. And at some point, I really didn't want to design anymore. I mean, I'm talking for real. I was tired of, solving non-existent problems of people, that the consultancies think, people have this problem, let's solve it. At the end, it's an excuse to just design another product and fill the stores with more new products. So I was really unhappy, and I met Aya there at littleBits, and her idea was to have pieces at a component level that can be assembled together, and each piece has a different function. These existed already in the electron, but she wanted to add the interaction level to the system. So, and I found it really interesting, because that would mean that you leave the interface to the people. So now, actually designing the electronics only takes like 10% of the time, and the other 90% is actually building the interface. The same way software is evolutionating. Like, for example, if you're doing music production, you don't have to spend like most of the time, or 3D. If you do 3D design, you don't have to spend that much time actually battling with the program, and you have the majority of the time for your creativity and to actually think about the result, not about the media. And especially for kids, and also for teachers. A teacher doesn't have to be a physical computer engineer to teach kids about electronics, or teach kids about programming. So we came up, most of you probably know, but we came up with this collection of electronic modules that's constantly growing, and each module has a different function and a different components. They're color-coded, input, output, and orange is the wiring and the logic gate. So all of them snap together, and all of them, and you can't do anything wrong because the magnets won't allow you to plug anything the wrong way. And for me, the most amazing thing is, like, we do a workshop, and people, they do a mess in the table, and you're not able to differentiate what's a hot glue gun, what's the pressure sensor, what's the battery, what's the pencil, everything is mixed. So, technology really becomes another material, like a popsicle stick or like a pipe cleaner. Everything is mixed, and people, as I said, people spend like 95% of the time on the actual interface, using materials that everybody knows, like wood, cord, or foam, Lego, whatever you want to use. So first you build the circuit, then you have a good sketch it really quick. For example, I did this project in a couple of hours with soda bottles. It's an interactive piggy bank. When you put the coin, it leaves the eyes, and also if you squeeze the ear, it buzzes. If you can bring it to another level, depending on your on your building skills. If you have a laser cutter, you can do more complicated things like toys, and it really takes like nothing. And it's amazing when you do. This was the other in Maker Faire. This kid did literally in like 20 minutes did this interactive postcard for his mother, and he would touch it, and the head was like going crazy with the googly eyes, and it's amazing what they can do in 20 minutes. Actually, parents see the littleBits, and they have problems in imagining what is my kid going to do with this. Everybody's asked, well, you guys should do like project kids, but I mean, you give a kid to a kid, and they don't have any problem imagining what are they going to do. So, so there were videos here, but maybe I'll just explain. So,
You might play if you go to full screen.
Oh, yeah.
Next slideshow or something.
Yeah.
Very bottom.
Yeah. It doesn't really play well. I'll just explain. So the idea is that in a table, when you drop all the bits, you have different interfaces, different technologies that they might never be in the same place. Like for example, we did a workshop here, and somebody did a bubble machine. So in half an hour, they did a bubble machine that you could bubble, you could blow bubbles just like clapping with sound activator module. But the same way, you know, some intangible interaction, like the first example I took from Leap Motion, is trying to mimic nature. You can still mimic nature. For example, what you would do to blow a bubble would be actually blowing. So in this case, you're blowing to a...
He's giving you time.
Yeah, no, because you know, I'm trying to explain the video, and it's difficult because the videos are here. So basically, yes, what it does is that it kind of repurposes the function of the actual sensors, because you know you allow room for unexpected things to happen. That because it's not linear, it's not scripted, it's just open to do whatever you want in space. So that may be. Yeah, that's it.